So we now know that when that earthquake occurs, we're going to get liquefaction and lateral spreading because the sands aren't strong enough to resist. So what do you do about it? Well, obviously you want to contain and prevent the lateral spreading from occurring, and two, cap this waste material. In this sketch, the waste is depicted by the white. And cap it so that when it liquefies, it can't get to the surface. It only manifests itself as settlement, not as sand boils at the surface. There's been studies done since Loma Prieta. I was in graduate school at the time that the Niigata earthquake occurred in Japan, and the Great Good Friday earthquake occurred in Alaska. And my professor was H. Bolton Seed, who coined the term liquefaction. So from 1964 to the present, there have been numerous studies performed, numerous techniques developed to first understand the problem and to deal with the problem. We are blessed in California to having the University of California, Berkeley, people like Tom at USGS that spending their career trying to understand this liquefaction. Furthermore, we're very fortunate that we have an excellent relation with the Japanese, who unfortunately experience a lot more earthquakes than we do of significant magnitude. As Dr. Holzer pointed out, you saw the picture of Kobe. There were other areas of that wharf where measures had been taken to mitigate the effects of liquefaction and lateral spreading, and there wasn't any damage. But we've learned from the experiences of Japan and the techniques that they've used how to deal with the problem. So how do we deal with the problem? Well, a gentleman by the name of Ishihara, thank you, working with Professor Seed, studied the amount of soil that would be needed to prevent the liquefaction from manifesting itself at the surface. And we know that if we can provide 10 to 15 feet of well-compacted material above the liquefiable material, that we know that the sand boils and volcanoes, etc., will not manifest themselves at the surface. How do we know that? Because again, we've had Japan to show us that. We also know that if we use ground improvement techniques, Tom mentioned a few, vibroflotation, there's compaction grouting, there's stone column, there's jet grout piles. There are numerous methods. We know that if we create a buttress around the landfill, so that when this liquefies, first of all, we're not going to let it get to the surface, and now we have to prevent it from going into the bay. We can create a buttress around the solid waste landfill that will prevent its movement. How do we know that that will work? Well, again, we have the experience that we've gained from observing the conditions in Japan, but more importantly, I'd like to quote to you from a paper that was published in conjunction with Dr. Holzner's report. And it was a paper written after the Loma Prieta earthquake by Professor Jim Mitchell, who again was one of my professors at Berkeley. And he wrote, what he did was, after the Loma Prieta earthquake, he traveled around the Bay Area to see what the consequences of liquefaction were on sites that had been improved by one of the techniques, whether it be the placement of a cap, the use of compaction grouting, stone columns, vibroflotation. There's all kinds of buzzwords that are used. But let me read to you, if I may, what he had to say. Here we are. It's a paper, it's entitled Improved Ground Performance During Earthquake. And this is a paper by Jim Mitchell and Frederick Wentz. And what he says in the introduction, without exception, little or no distress or damage due to ground shaking occurred either to the improved ground or to the facilities and structures built upon it. At many studies sites, unimproved ground adjacent to the improved ground cracked, settled, owing to liquefaction. At every studied site where the ground shaking was severe enough that liquefaction of the unimproved ground would be predicted to occur, did occur. Together, these results support our conclusion that, one, we know how to predict liquefaction and lateral spreading, and two, we know how to apply ground mitigation techniques that reduce and or eliminate the risk from liquefaction. And I would suggest to you that I will do everything in my power, and I know that the city and county of San Francisco will also, to make sure that before the city and county of San Francisco accepts this property from the Navy, they will have either implemented an appropriate mitigation plan to eliminate the risk or provide the city the money to do that. Thank you very much for listening.